We have another great example here. We have a beverage filling station here. In this station, bottle caps are being controlled, and after the filling is done, a sensor checks if the bottle cap is in place. And faulty bottles are kicked out of the band 9 steps later. In the market, there are different types of sensors which detect these. In here, if we don't see the bottle caps, we accept that as a fault, and after 9 steps, the bottle is kicked out of the band. Look. This sensor detects the fault on our bottles. Look. Our sensor detects the fault, and after 9 steps, look. 1, 2, 3, 4, 5, 6, 7, 8, 9 steps later, this bottle is kicked out through the dispense cylinder. The piston moves down, and what happens when it does is it kicks our faulty bottle out. Our system is like this, and in order to understand, think this. Think that our band works at a 1 Hz pulse, and at each pulse, the bottles or the conveyor belt moves step by step. Think that this works with pulse and this moves forward with each pulse like this. First step, second step, third step, fourth step. Just assume that it moves forward slowly. Our system is like this. The set bit of our sensor which detects the faulty pieces is M8.6. There is our bit that says the bottle is at the dispenser location is M9.5. I have addressed these as such. Look, I will also tell you this. Look, there you see the byte and bit numbers. Look, that is my 8 byte and 9 byte. The bits inside my 8 byte, look, 7650 bit again, the bits inside 9 byte. What will happen now? After 9 steps, starting from M8.6 here, look, at every 1 second pulse, my band here moves. My piece is here now, first move, second move, third move, fourth, fifth, sixth, seventh, eighth, and ninth move. After ninth move is complete, my cylinder detects the piece, or rather, it knows the piece detected by the sensors 9 steps before will be kicked out, and at the end of the 9th second, this piston will move downwards and that faulty piece at M9.5 will be kicked out. The system works like that. It's coming from 8.6, I am counting 1, 2, 3, 4, 5, 6 steps, 7 and 8, and at the end of the 9th second it comes to M9.5 piston and it kicks it out. Look, there's a situation here. Let me tell that to you. The thing we want to show you here is the importance of the numbers of bytes and bits. We have told you before that the byte number increases starting from left to right, and bit number increases from right to left. Maybe you thought this information was trivial when we have first told you. But now it is important. You need to know it in order to actualize this process. Look, my 8 byte, 6th is this. 9 steps later, when it comes to 9, this piston will push it and will actualize the process. You have to know the features of the equipments that you use frequently. For example, in this simulation, your sensor can detect the situation of bottle caps. You can use different sensors to detect color on the bottle, or a hole, or rather a bruise on it. Or think of a jar and you can detect cracks on it. If you have a metal box, you can detect bruises on it. I have placed a pulse here, which will create 1 pulse every second, and it will carry my band 1 step forward with each pulse. For this, I have selected M05 in the Merkur field. I will get back to the clock memory byte that I told you before. It's 0 here. I picked my byte as Merkur, or rather, a clock Merkur field. I have operated here using shift instructions. When I press 00 here, that 00 is my sensor actually, my sensor detects the faulty piece. When it detects the faulty piece, it resets the byte called 8.6. It is actually a bit. Look, 8.6 bit is getting set. What happens when 8.6 bit gets set? This value here, the, you see, will start counting. How many steps will it count? It will count 9 steps. What is the 9th step? Our 9.5th bit, meaning M9.5, will give energy to Q00 when the faulty piece passes 9 steps. And Q00 here is our piston. The piston does its work and comes back. I will explain the comes back part here. Think of a spring using mechanism, meaning a hydraulic piston. Hydraulic piston gains energy first, oil line opens, and after it is done, you withdraw it using a spring, and because of that, you need to select the piston you'll be using. Lock. Let's open our software now. Pick up the glasses. Now, my simulation works like this. I will show you in a minute. How this works. I have added all entries and impulses. Look, the moment I sent the signal, the moment I sent the signal to this 00, what happened? My band here started moving step by step. It moves step by step. There, when it comes to 9.5th bit, when it comes to that, Q00 gained energy, and there, that is my sensor. That one you see. It will detect the faulty piece, and in the end our sensor will pick some faulty pieces because no manufacturing line is perfect. For example, the band is running now, the system is running, and a faulty piece is detected. What happens when it is detected? Look, it started counting step by step, and when it comes to the 9th bit, 9th step, the piston there worked. We will count our process again. Look now, 8, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Look guys, when it came to 9th step, the piston kicked it out. Our system operates like this, and this application is a good one, as I have told you. You can use it with automation systems in factories, for example. It is a multi-use application. Our aim was to actualize all our examples in accordance with real life and show you the use of commands here.